Here we'll review the names given to the sides in right triangles. Now right triangles are triangles with a right angle. So first, which of these are right triangles? And if you don't remember what a right angle is, click down here instead. Great! Now take a look at this right triangle. This side over here, which is opposite the right angle, is the longest side of this triangle. Now the longest side of any right triangle is called the hypotenuse. So take a look at these two right triangles over here. Try identifying the hypotenuse for these two right triangles. Nicely done. And the other two sides of a right triangle are called the legs of the right triangle. Let's say we've labeled one of the two acute angles in this right triangle, like this one over here. The leg that's on the opposite end of the triangle from this angle is called, appropriately enough, the opposite side. Again, take a look at these two right triangles over here. For these two yellow angles, identify the opposite sides. Finally, the remaining leg of the triangle, which along with the hypotenuse forms this angle we're looking at, is called the adjacent. So now for these two yellow angles, identify which sides are the adjacents. Great work! So to summarize, the longest side of a right triangle is called the hypotenuse, while the other two sides are called legs. And if you're looking at a specific acute angle in the right triangle, then the legs of the right triangle are called the opposite and the adjacent. The opposite is the leg opposite the angle, while the adjacent is the remaining leg. For this triangle, we've been looking at this angle down here. But if we were to look at this angle up here, then the opposite would in fact be this leg down here, because it's opposite this angle, and the adjacent would be this leg over here. Here we'll introduce the sine function, which is a function whose inputs are angles. But first, let's take a look at a right triangle, like this one. This is a right triangle because this angle over here is a right angle. Now suppose this angle over here is 30 degrees. So at this point, you know two of the angles in this triangle. Try using these facts to calculate what this angle is up here. If you're not sure, click down here. Right, this angle is 60 degrees. Now let's look at a few more right triangles with the same 30-degree angle over here. All these triangles are similar, meaning they all have the same three angles and their sides are proportional. But this triangle is smaller and this triangle is bigger. The longest side of each right triangle is called the hypotenuse. Now for each triangle, identify which leg is opposite the 30-degree angle. And if you're not sure what an opposite side is, click here to review the side names of right triangles. Nicely done. These three sides are all opposite the 30-degree angles. Now suppose the hypotenuses for these three right triangles are 4, 2, and 7. And let's say the opposite side for this right triangle is 2. Using the fact that these triangles are all similar, find the lengths of the remaining opposite sides. And if you're not sure how to do that, then click here to review. Right, this side has length 1 and this side has length 3.5. Now we're about to say exactly what the sine function is, but first, for each triangle, let's calculate this fraction, the length of the opposite divided by the length of the hypotenuse. We'll do this first triangle together. The opposite has length 2, and the hypotenuse has length 4. So this fraction equals 2 over 4, which equals 0.5. So now calculate this fraction for the remaining two triangles. So for each of these triangles, the opposite divided by the hypotenuse equals 0.5. This turns out to be true for every right triangle with a 30-degree angle. If you take the length of the side opposite the 30-degree angle and divide it by the length of the hypotenuse, you always get 0.5. Now this ratio of opposite to hypotenuse is the sine function. In other words, the sine of 30 degrees, which you can write like this, sin of 30 degrees, equals 0.5. So the sine of an angle equals its opposite divided by the hypotenuse when that angle is in a right triangle. Let's look at another example. here's a right triangle, and let's say this angle down here has a measure theta. And let's also suppose that this side has length 11 and this side has length 14. What's the sine of this angle theta? So now it's time for you to calculate the sine of an angle using this interactive right triangle. You can drag around this corner in the upper right to make any right triangle you want. As you move the corner, you'll be changing this angle down here. Also shown here are the lengths of the hypotenuse, opposite, and adjacent sides of this triangle. So try using this interactive right triangle to find the approximate value of the sine of 53 degrees. And if you're not sure how to get started, feel free to ask for a hint. Great work! Now one last question. Use this interactive right triangle to find an angle whose sine is approximately 0.4. Again, feel free to ask for a hint if you need one. Here we'll introduce the cosine function. Now here's a right triangle, and suppose its sides have length 3, 4, and 5. And let's say this angle over here is theta. Before getting into the cosine function, let's make sure you remember the sine function. What's the sine of this angle theta? To review the sine function instead, just click over here. Nicely done. To calculate the sine of this angle, you looked at the length of this side of the right triangle, called the opposite, and this side, called the hypotenuse. The sine of an angle is defined as the length of the opposite divided by the length of the hypotenuse. Now the cosine function uses this third side of a right triangle. Do you remember what this side is called? If not, click here for a refresher. Exactly. This side is called the adjacent. So for the sine function, we looked at the opposite divided by the hypotenuse. For the cosine, we'll be looking at the adjacent divided by the hypotenuse. So cosine, written as cos, equals the adjacent over the hypotenuse. Now find the cosine of this angle theta. So now it's time for you to calculate the cosine of an angle using this interactive right triangle. You can drag around this corner in the upper right to make any right triangle you want. As you move the corner, you'll be changing this angle down here. Also shown here are the lengths of the hypotenuse, opposite, and adjacent sides of this triangle. So try using this interactive right triangle to find the approximate value of the cosine of 53 degrees. And if you're not sure how to get started, feel free to ask for a hint. Great work! Now one last question. Use this interactive right triangle to find an angle whose cosine is approximately 0.3. Again, feel free to ask for a hint if you need one.